Hello, chemistry students. Today we're going to talk about determining ionic compounds formulas from the names. Sometimes you will be given a name or read a name in a lab, and we will need the formula in order to do our calculations. Now this is a pretty easy process because it is an ionic compound which bond the same way all the time. So what we're going to do, this is just an extension of the swap and drop. If we're given the name beryllium fluoride, first thing you need to do is write down these symbols for the elements and their oxidation numbers. So beryllium Be, and we know it is a alkaline earth metal, oxidation number +2, fluorine's a halogen, oxidation number -1. We get that right off the periodic table. Next step is to do the swap and drop. Just like we've been doing before, beryllium is a cation of +2 and fluorine is an anion -1, and we swap it so that we end up with 2 times 1 is 2, 1 times 2 is 2. We have a neutral compound when we have 1 beryllium atom per 2 fluorine. So let's try another one, another easy one, lithium oxide. First step is now you're going to write down the names, the symbols for the element from the name. This is a name. And the oxidation numbers. Lithium is a +1, oxygen -2. And we'll do the drop. Now don't forget to check for the lowest ratio of each type of element. Lithium, we have 1, oxygen 2. There's no way to reduce that into a lower whole number ratio, so we're good to go. So this time, we're going to start looking at the polyatomic ions. This is the new stuff. You learned what a polyatomic ion is in a previous assignment. And the one key thing I'm going to tell you, if you see a name, this is a name, sodium sulfate, and it doesn't end with IDE, it's probably not just a binary ionic compound, binary meaning 2 elements. It's probably 1 element and a polyatomic ion. So we need to go on our polyatomic ion list on page 7, and we're looking for sulfate. So you kind of look, and I found the sulfate polyatomic ion. The formula is SO4, and it has an oxidation number of -2. So what we're going to do is just the same. We are going to write down the element and the polyatomic ion with the oxidation numbers. Then we do the swap and the drop. And we end up with, we bring this a -2. We bring down the 2. We bring down the 1. We drop, we clean up, we leave off the oxidation numbers. The 1 is assumed, so we don't have it here. Now the key thing that students get confused about and forget with the polyatomic ions is that the subscripts that are with the polyatomic ions never ever change. This is a group. So this sulfate, SO4, is a group that is together. And we do not ever reduce the numbers that are on this list. I will show you when we do reduction, I will show you that next. So this is Na2SO4. We're not going to reduce this 2 and this 4. Because this SO4 is one group with an oxidation number of -2. Now let's look at magnesium hydroxide. First step, I'm looking here. Now this ends in IDE, but I can't find the element on the periodic table. If you can't find the element on the periodic table, I will go ahead and take a look on your polyatomic ion list on page 7. And right here we have hydroxide, OH-. We'll see those a lot because many bases have hydroxide as their anion. So magnesium hydroxide. We will write down the symbols and the oxidation numbers. Then we'll do the swap and drop. Now here is where we have to remember. The OH, the hydroxide, does not have any subscripts, but we have two of them. So what we do is we need to put a parenthesis to tell people we have two of these polyatomic ions. If we didn't do that, it would look like we had just two of the H's. But no, not two hydrogens, two of the hydroxide ion. So be very careful with that. So magnesium hydrogen carbonate. Step number 1, write down the elements and with their oxidation numbers. Now hydrogen carbonate, we need to be careful. We have the ATE. And hydrogen, we haven't done anything with 3 elements. We're only doing binary. We are only bonding a cation to an anion. So if you see 2 more like this, there are 2 cases on our polyatomic ion list with 2 words. And today we are using the hydrogen carbonate, HCO3 with a negative sign. So we start out by writing down our cation and anion and their oxidation numbers. Then we're going to do the swap and drop. Bring down a 2 from the magnesium, the 1 from the hydrogen carbonate. Now here's where you have to be careful. We need the parentheses telling us that we have 2 of the hydrogen carbonate polyatomic ions. We never touch this, what is inside, what is part of the polyatomic ion. Now this, what's outside the parentheses, can sometimes be reduced. And here's an occasion where we were. If we have magnesium sulfate, wrote down the magnesium and the sulfate, oxidation numbers, we did the swap, and now we're going to do the drop, and we end up with 2 magnesiums for every 2 sulfates. Well, that is not the lowest ratio. 2 goes in the 2 once, 2 goes in the 2 once. The lowest ratio of magnesium to sulfates in this compound would be 1 to 1. So the formula would end up being MgSO4. And that is getting the formulas, which is here, from the names, which is here. And ionic compounds. Just remember, this is always metals plus nonmetals. Cations and anions. Hope you have a great day.